Hello everyone, and thank you for joining us on Earlymark Spec the Truth series. Today we're diving into a critical but often overlooked topic, passive fire protection. And to guide us through this, we have not one, but two experts in the field. A big welcome to Chris, a passive fire protection expert with over 20 years of experience, and Nathan, a passive fire protection manager with extensive hands-on experience. Chris, Nathan, thanks for being here.
Hi Michael, it's my pleasure. Thanks for having me. It's a topic I'm passionate about, so I'm happy to shed some light on it.
Likewise, Michael. I'm excited to join the conversation and share insights for the practical side of managing passive fire protection systems.
Awesome, fantastic. So look, let's start with basics. For our listeners who may not be familiar, what exactly is fire protection and why is it so important to modern construction?
That's a perfect place to start, Michael. Think of a building fire safety as having two parts, active and passive. The active systems are things that do something in a fire, like sprinklers, fire alarms, the noisy and wet side of the business. And then passive fire protection, often referred to as PFP, is about the building structure itself. It's the design and materials used to contain a fire, limit its spread, and maintain the building's structural integrity long enough for people to evacuate safely. This includes many items: fire-resistant walls, partitions, ceilings, floors, and crucially, from our point, protective coatings on structural steel elements, beams, columns, etc. It's a silent guardian that's built into the bonds of a building.
Yeah, great way to put it. So that silent guardian. And now you mentioned protective steel. I want to jump into a specific issue that seems to cause a lot of confusion, particularly in the Australian market: limiting steel temperatures. There seems to be a lack of clarity here. What do you think the core of the problem is?
You're certainly on a major point of confusion, Michael. We know that when steel gets too hot, it loses its structural strength and can lead to structural collapse. So we've got to determine what we call the limiting steel temperature or critical core temperature, different terminology. But for a steel in a specific project, this is the maximum temperature the steel can get before it starts to lose its strength under a design load. The problem is there's no single universally applied number. There's guidance, particularly from the UK, of 550 degrees C for columns, 620 for beams, but it is only guidance. The correct limit steel temperature depends on the specific loads that a particular steel element is carrying. A beam under a much higher stress will fail at a lower temperature than one that is lightly loaded.
Yeah, thanks, Chris. So, Nathan, I want to bring you in on this. If it's not a one-size-fits-all number, that brings me to a follow-up question, which is critical, and that is, who's responsible for figuring this out and who should be doing these calculations on a project?
It's a great question, Michael. It's one that often gets misunderstood. As Chris mentioned, limiting temperature depends on the specific loads acting on the steel. That's where the structural engineer comes in. So they're responsible for calculating these loads, including dead loads, live loads, wind loads, and determining the appropriate limiting temperature for each element. So once that's done, it's my role as a passive fire protection manager to ensure the right products are selected and applied to meet those specifications.
Wow.
Yeah, exactly, Nathan. The structural engineer has a complete picture of the building with the various design loads. So they're the only ones that can make a call. It's fundamentally part of ensuring a building's safety is protected correctly.
Yeah, awesome. That's powerful, and thanks for clarifying. It's just so listeners and myself understand. So the process should be: the structural engineer calculates and specifies the limiting temperature. Then yourselves, the passive fire protection specialists, select the right product to meet that specific performance requirement. So for our listeners who do tend to be architects, After receiving expert opinions from structural engineers, you can utilize this information, cross-reference it with pre-authored product descriptions within Earlymark Spec Suite. So it's super easy. Information you get from engineers, what's in Spec Suite should make it nice and easy to select that product and include it in your documentation.
Precisely. It removes the guesswork and ensures a protection system is genuinely tailored to the building's unique structural design. It's a much safer, more accountable process for everyone involved. Additionally, it's important to discuss the product loading schedule with the manufacturer. This step ensures that the fire protection products are applied accurately and in compliance with the project's specific requirements, further enhancing safety and efficiency.
So, team, a lot of choices around steel sizes and structural elements seem to happen pretty early on, and it feels often without considering fire protection. So, Chris, Nathan, can you shed some light on how these decisions impact the fire protection strategy down the line?
Absolutely, Michael. What we often see is that steel sizes are selected primarily from a structural perspective. Engineers aim to use the minimum steel sizes that meet the design requirements from a strength and stability point of view. While this makes sense from a cost perspective, initially it can create challenges from a fire protection perspective. Then the steel sections heat up fast, which means more fire protection materials is needed to maintain fire resistance. Early collaboration between the structural engineers and the fire protection specialists and manufacturers can make a huge difference. For example, upgrading to a larger steel size section early in the design process can reduce the amount of fire protection material that's required. This can lead to cost savings, faster installation, and a more integrated design.
Chris is absolutely right. When fire safety is considered from the start, it's easier to create a holistic solution that balances structural and fire protection needs. It's about breaking down silos and working together to design safer, more efficient buildings.
Nathan, I want to shift gears for a bit. So we've established the importance of getting the engineering right for safety. But another huge topic in construction right now is sustainability. Help me understand, how does passive fire protection fit into the green building movement?
It's a fantastic question. It's an area that has seen incredible innovation. For years, fire protection materials were judged solely on performance, but now we're asking more. We're looking at the entire life cycle of these projects. From the raw materials and manufacturing process to their impact on indoor air quality and what happens to them at the end of the building's life. Sustainability is no longer an afterthought, it's a core requirement for many projects.
Chris, can you give us an example of how this is being applied in projects themselves?
Yeah, absolutely. A great example is a new generation of alternative vermiculite cementitious sprays, like Carboline's Perlifoc HP Eco Plus. This isn't just a high-performance fire protection product. It's been designed from the ground up with sustainability in mind. It's made with recycled materials. Packaging is incredibly lightweight, which reduces the carbon footprint associated with transportation. Furthermore, it's extremely low levels of volatile organic compounds, or VOCs, which is a major factor for maintaining healthy indoor air quality.
Nathan, from your perspective as a passive fire protection manager, how do you see sustainability influencing the future fire protection strategies?
It's becoming a key consideration, Michael. Many of the projects I work on now have strict sustainability goals, and fire protection products play a big role in meeting those. Products like the Perlifoc HP Eco Plus not only meet fire safety requirements, but also contribute to green building certifications like LEED or WELL. It's a win-win for fire safety and sustainability.
Yeah, awesome. Before we wrap up, guys, I know that the cost is always a major consideration for builders and designers. Can you give us a quick overview on how different fire protection solutions compare when it comes to price?
Absolutely, Michael. It's important to know there's quite a a vast range depending on the type of solution and specific requirements. Just for example, ballpark figures, a 2-hour rated intumescent coating system, such as Nullifire SC902, cannot cost anywhere from sort of $400 a square meter to over $1,000 a square meter, depending on the level of finish that you're looking at, etc. On the other hand, a vermiculite cementitious spray product like Perlifoc HP Eco Plus are more affordable, typically around sort of $150 a square meter for a similar rating.
Wow.
And from a management perspective, it's worth noting that early collaboration can help minimize or optimize costs rather. By considering fire protection requirements during the design phase, we can often find solutions that balance performance and budget more effectively.
Yeah, that's great. And, it really helps put things in perspective. Cheers, guys, for breaking that down. And Chris, Nathan, this has been an incredibly insightful discussion. You've cleared up a lot of ambiguity around steel temperatures, showing us how safety and sustainability are coming together and providing practical advice for managing costs. So thank you both for sharing your expertise with us today.
Pleasure, Michael. Thanks for having us.
Thanks for having me too, Michael.
Thanks, guys.